My name is Jamal Al-Abeid. I am a retrofit coordinator and also working for University of Bradford, program leader for architecture, technology and engineering, undergrad and postgrad. We had a webinar, CBD webinar last time on BAS 2035, but was an overview on the document as a whole and the process that the coordination of any project, especially for retrofit coordinators and designers, go through. But this time, the part 2 is focusing on the digital and the technology used and recommended by the document or the standard. Like BAS and SAP and PHPP and also like WUFI. But today our focus will be, as I said, on a few softwares. I'll try really to spend more time on explaining the theory behind these softwares and why probably is recommended. I've shared these slides, but we will look at the compliance document, this workout sheet. It's an Excel sheet, separate sheet, the BAS 2035 compliance document. But before that, I will start with SAP, because the input data should be either from PHPP or SAP, most of the data. So mainly I will go through the SAP and the compliance document, but also probably another time I would like to share some advice and probably tips on using other softwares like the WUFI, especially passive WUFI passive software, which is integrated with PHPP and also the Design PH. It's a plugin used with SketchUp, so it's just a quick way and ensures that the model that you are working on has all required data in terms of the thermal envelope and other things like shadings, everything else really. So you can start with this, the Design PH, then you export the model to WUFI, then you do the hygrothermal analysis, ensuring that ventilation is okay and there is no condensation or anything or mold growth over the next 5 or 10 years. So, but this is another part of the sorry, I'm not sure why my slide says. So I'm not really spending time on looking at a presentation, rather than I'll take you through the application. I would just start just quickly show you why we need to use SAP here. So sorry, when you have the where we need to use SAP here, sorry. So we need most of the data when we use this document, the work the compliance document here. So we need well, not few data, but many data here. So we need to extract this data from the SAP worksheet, the heating, the hot water, the electricity. So the existing data will be taken from the project, so from the building or from the house or flat, but the other data will be taken from SAP. So you carry out an individual improvement on SAP and you bring this data. to the software, and this is why we need to look at SAP first, and then bring these data here. So the version of there's two versions of SAP: the full SAP and the reduced SAP. Reduced SAP usually is use it for existing buildings, so it's quicker to use, less input data. Full SAP requires more data, but can be used for new and existing as well. So this version is not up to date really. It's 2012, sorry, version. But just the update is the default data, so being updated in 2016. This version is from Stroma, but has similar interface, slightly different from the full SAP version 2016. So this is what you got when you start the app, and then these are probably typical tabs. You see them apart from the lodgement of the data. So when you lodge the project, then you got a record of this on the server, and then you generate the reports from here. But I will start with these tabs here. So new project, then you insert a new building, and these are just saving document and when you see your reports. Let's just go ahead and start with this. So once you start a new project, you'll get this data, a record of the project like details. So the project name, whatever the project name, let's say block of flats, or could be any name. You have reference, then the address of the let's say Leeds, sorry, somewhere street, and then let's say Leeds, country, UK. You put the postcode LS something, and all this, the client, your client, who's your client, and then again the details of the client here. If you have an existing client, then you should have a record of the client details. Then this is just the project information, so it should be filled, but just not necessary for the exercise of today. And then you generate a new block or a new building, and you got all of this drop menu, and all of this have to be completed. The house details, of course, you can, if it's flat, then you can name it flat 1, let's say, and then if you have a number of flats, you can have another one and just call it a flat 2. Sorry, yeah, flat 1 and a flat 2. So it depends on, but let's just stick with that, with one building, so not to confuse everyone. But it's same thing. So this is like individual blocks, then you go through each one. So the flats, you have to do all of these details, the reference that you already put there. Of our heating in summer is included or not. Date of assessment, let's say today. The type of assessment, whether it's new or existing, let's say existing. Transaction type, so probably let's just say it's rental. The type of property, let's say rented social. Related party disclosure, usually not related unless. So this is about the thermal mass of the building. If it's solid walls, let's say, will be like the thermal mass is high, but let's say an indicative or calculated, let's say indicative value, unless you know this value. So let's say an indicative of medium. And then the address here, let's say again, leads, postcode, let's say LS1, just putting really random address, and then England, let's say. Here probably an important, if it's a flat, then which flat and where this flat is it top floor, medium, or ground? Say medium. Or if it's house, then whether it's detached or so. It's a very straightforward details. The type of flat, let's say this. Well, if it's built like, let's say 0.5, and this is also an important, if it's relatively new, then there will be the full data for, again, probably I forget to mention that some people, they consider this as a problem for SAP, so lots of default information. But as long as you have an accurate data, then shouldn't be a big problem really, because this relies on the information you provide to the software, especially for the how old the building, the thermal mass of this, and then the data you input later throughout this. But there is a lot of default data calculated, like the occupancy of the property. Location, of course, there will be around this. It's not something an exact location, but let's say somewhere northwest England. This is also, there is wind factor and all other information. Will rely on the location of the property within the urban area. Let's say is medium or low, not within the city center. Orientation, let's say, this would be an important, especially for the main facade. So when you have windows, and this is quite important really for the software. Let's say south. So it's just telling you that your openings will follow this as well. Let's say no, overshading and average. So yeah, so these are the information for the flat here. So once it turns green, that means it's completed. So all of these, we have to complete them, but it's just shows green here. So the dimensions of the flat also, if there is a basement, then if there's no, of course it's a flat, so we say no. And then the area, you can calculate, of course, the area here. So 1 by 1, room by room, but also you can just have a roughly idea on this, let's say 70. The height as well, so 2.3, let's say. Of course, it is one flat, so we don't need to, unless you are doing a 2-story building, then you can. Here it's just calculating the volume of the flat, and this is the living area relative to the other rooms. So let's say living area is not including the bedrooms and all this, just the living room really. Let's say 18. So then will show the relative to the other area. Okay, this is quite clear unless you have a question about this. So the opaque elements, which is the walls, especially and roof and floors. This is the thermal bridge. So
Sorry,
it
Jamal,
can be
can I just ask, is the area gross internal or net area?
the area. Which one?
We've just got a question asking if the
Yeah.
area is gross internal or net area.
No, this is the internal area of the flat. So, well, the SAP will consider this as an internal area. So this is also because when you go to the BAS 2035, they will consider the cross internal area, and the cross internal area, well, obviously will include the walls, partitions, and this, but this area is the internal area, so room by room. Okay, so it's the that's why here, if you go there, how can I go to the this? So if you go there, you see clearly this is calculating room by room. So the first room, I say internal dimensions, like pi meters here, 3.1 times the let's say 3.4. So you're calculating the room by room, Natasha. Is that clear?
Yeah, that's okay with me.
Okay, so thermal bridge, bridging here, probably, I don't know if people are familiar with this, but if you are not sure, adding element by element here, whether it's cell or jump or ground floor. So each one will be added here, and then if you are not sure, then leave the estimated, like the software will estimate this, but you can really go through this if you know how to calculate the psi value and this, and then times by the length. Probably some people not familiar with this, but if it's some elements are clear, like the roof, floor, so it's just like, but some of them there is a special calculation to calculate the C value and the depth of this, then times the length, how, especially if it's balcony, or because there's a few types of thermal bridging here. It's like one we call linear, non-linear, and things like penetrating the envelope. So some people refer to punctual, but I would really say that unless you know how to probably to go one by one and to how to calculate the to accurately know the length and the depth of the bridging, this called bridging area, then leave it to be estimated, so calculated by the software. Sorry. Then you got three elements here. One the external elements, one is the party elements, and the internal elements. So these are the external floors, external walls, and external roofs. So external floors, we don't have a diagram shows this, but external floors is probably if you have an extended floor on the second or third floor, then that floor would be an external floor. So you type that, for example, let's say, well, room 1, and it is, let's say, exposed external floor, could be even a ground, so like the building extended, The type of this, of course, you will put the area and then this and this, but the type, if it is timber exposure floor, if it's insulated or not. The area, again, you can calculate the area, but let's just put rough area. So let's say 8 meters here. Here, the U value, if you know the U value, you can put it here, or you can even calculate this from here. So
crispy.
you,
It's nice and crispy, a slightly little bit burnt on the top. Pretty shit on the bottom.
Yes, please, Natasha, if you can read any question here, because
hotel, haven't you? I want to stay here.
Yeah, but it's too expensive. I'm not paying it. I agree not to pay.
hello, I can
So what's
hear
wrong with the one
someone.
that we hearted down below?
Can you all please make sure
Straight
that you've got your microphones off, please? Thank you.
If you have any question, please just put it on the chat box. So I just want really to give an overview of the software. So what exactly the input data, so the envelope, the openings, the ventilation, but when you come to the opaque elements, you will have to fill all of this information. I'm just giving an example, quick example here. So you just add a new element, whether it's wall or roof, or let's say here we're talking about floor here, so we'll be here. Oh, sorry. You put a new floor, and you can name it, of course, but so you use this these elements here to put them there. So you have existing material. If you're not sure, there's a plenty, really big library here, but you can rely on the default area. Of course, you can put your information, your input data here. But if it is like, let's say, so the one on the bottom is the external, and then this is the internal. So this is really important here, because there is a resistance, thermal resistance value here for internal and external. Some people probably, if you're not familiar with this, then there's a few conditions here. This is quite important. So the surface thermal resistance here will change, depends on the direction of the thermal transmittance. So let's say an internal here for the floor. Internal here is the inside, the external is the outside for the floor, and the other way if it is roof. So the internal, let's say, what do you got here really? Timber, let's say. So you put that here, just grab it from here and drag it to this one. Double click, you can get some information here. You can change it, thickness of that timber. So in, let's say, what's the thickness here in millimeters? 15 millimeters, let's say. So it gives you the conductivity. If you're not sure about the thermal conductivity of this specific timber, you can change it as well. So this is for this material. Let's say update and put it there. Let's say there's an insulation, so you can go either choose an insulation material from here, or just you go to the insulation here and select whatever the insulation. Expanded polystyrene or extruded, which is EPS. Let's say here, put it there. Put the thickness at least of that, like 150. Okay, gives you the conductivity. All right, so whatever the material, and then the external one, if it's suspended floor, then and also if we right click, you can move this material up or down, of course, to get this. You can see the calculation, of course, here, and you can edit the whole information from here as well. But there's a few information here. If it is solid ground floor or other than ground floor or suspended floor, probably it is recommended to select the right like type of floor here. So this is about the other things is really by default calculated. So the surface resistance, thermal resistance, the conductivity as well. But you still can change them if you think they're not representing the right. Okay, then so this is the sorry, one second. So the user, I just want to see how to change that name. Yeah, I want to change the name of that. Yeah, from edit. So you can change here, let's say floor, whatever the name of that floor 2 or level 2, or so you can just refer to this later. Okay, so that's the you can add another element, but we can add it later in the same way. Now if you go back to this and right click, oops, sorry, right click, then and you want to, sorry, you want to insert the U value of this, you need to select it because it's been calculated. So you can, oh sorry, you can edit it, of course, later if you remove it. So the same way you do with this. So if you have other floors, you can add them. Same way with external walls. Let's say south wall. Oops, sorry, south wall. Type of wall, exposure, let's say. If it's cavity or solid wall, then you selected the area of that external wall, let's say 44. Same thing, exactly. You can consent manual and just, oops, and you edit value. So you go this and you add wall. Same thing, exactly what we did. So you just you name it here like south wall. But I haven't done everything here, but you can same thing, really go to the material, and then by default here you go to the wall, oh sorry, and you choose the material, the out one, the internal one, and then you can have polystyrene or just insulation from here. I'm just thickness of this, oops, thickness of the insulation material. Okay, and probably the material will be, if it's cavity, then will be in the middle. So anyway, so this is exactly to you confirm this, and you have the, there is here there's, oops, if there's anything attached to that particular wall, then whether it's a storage, whether it's garage or anything, so you probably need to select it. That will affect really the calculation. Again, if you have north, let's say, wall, then you do the same thing, really exactly the same thing. I'm not going to probably imagine if it's the same assembly, then will be like this. Same thing with external roof here. So you just name it roof, let's say. Again, the same, let's say insulated at rafters or joists here. Sorry, rafters here. Again, this is more important to calculate the U value, but probably the area are relatively the same as the floor area. Will be slightly more, really. Probably people would question if it's pitched roof in the same area. Same thing. You need to install this roof, and you give it a construction. You need to roofs here. So I'm just selecting really random. If it's tiles, an external, and then wood slab. This, so you can build this really if there's an insulation. Okay, but all you need to put thickness here. What is this? If it's insulation, let's say 150 meters. Wood slab here as well, thickness probably 8 millimeters. No, 8 millimeters. That's not 80. Sorry. And then this is, let's say, what is it? The tiles is just 12 millimeters. And now you realize this is internal and the external, so it should be this is an external, so move down, move up, let's say. So whatever this is the input. Okay, right, it's just selecting the roof here. Oh, sorry. All right, click, and then you select the roof. Okay, and that's the roof here. Openings follow really the similar approach. You add a new door and window here, and if you have any roof lights, so you name them. Let's say D1 or D2, that will be shown on the drawings, and then you have the walls that you built on. If it's south, and select that the south wall that's installed in the south wall. Calculated SAP 12, let's say this is if it's solid or not. Orientation as well, you can already mentioning this, an average, and you build this really. So the area of this in meters here, so let's say 2.1, or you just go to the depth and width in millimeters. It's like this height, let's say 2, okay, and this will be calculated. Your value will be estimated here. Other things here, so you select the type of glazing, the air gap between the double glazed here, let's say 12 medium type, let's say PVC thermal break. That will be calculated if you select metal. And then this will be calculated automatically, the value, the frame factor, and the transmittance factor as well, the G value, and all this information will be added there. You can edit them, delete it, whatever. You add window, same thing exactly. So you go to the location where the window is. So calculated by SAP, unless you have manufacturing details. If it specifies, then you can. So we say north, let's say, the level of shadings and this and this. So you do all of this. The windows, let's say, width 900 and height 1000. So basically, this is the information that you need. the overhang width, if there is an overhanging. So like level of shadings, this is the width. If it's covering the whole, then it would be 900. The depth, let's say 40. There is any type of constants used here, unless you need to fill all of these things. Really, I'm just selecting them randomly. Then if you have previous details, then you can copy them from that. But now you realize that there's all this transmittance value of the glass and this sense. Oh, there must be something that we haven't done. The name. So window 1. Okay. There's not much really. Let's say edit. This is everything. Okay, disappeared. You do the same if you have this. You go to the ventilation. So it depends on the existing type of ventilation. So you have PIV. You have if it's on the loft or outside. So till you got all of these kind of decentralized whole ventilation with extract. Natural ventilation, let's say. So the construction type, let's say masonry. If there is let's say it depends on the condition really. The floor is suspended or sealed here. No timber floor if it's in the middle, because we're talking about so percentage of windows to the door. Usually this is figure. Oops. Usually this is a figure. If it is an existing and there is no improvements, then that will be 50% or less. If there's an improvement, then that will heating type. There must be a heating, so a boiler with radiators here, or same thing if it's underfloor heating is the most common. Gas boiler, let's say, unless there's so let's say if you're calculating this from the database here, so you go to this. If you have an information from the manufacturer, then so let's just rely on the SAP calculation. The boiler type here. So there's a few options really added to the 2016, but this is where you have like when you have the outside open floor, and then type of heating. If it's combi, let's say, this will be another information. System with radiators, and then type of control. Usually there's a thermostat at least, one thermostat for the whole house, main gas. So usually standard. So unless you have this information, if the boiler in a heated space, then you say heated space. Pump type, unless it's no, and then the boiler, sorry, usually is 13 and later. Interlock, not quite sure, but all depends on the building assessor really, and the survey done area. Anyway, so there's more information here, type of if it's open or chimney, or and here there is secondary heating. If there's secondary heating, you need to include it, to select this and to choose this type of, if there's secondary heating, and if there's cooling system here. So, but most of the UK houses will rely on one source of heating, unless there's like portable like heaters, these portable heaters, you can add them really here. Let's just move on. Water heating as well. It could be from the main source of heating, or you could have the thermal, the solar thermal here installed, so you can also include this. Let's just do simple beefy panels. Usually they are not installed, but if they are installed, then you put the power. So say 250, and then or you calculate all of them. Really, it depends on the size of that 250 each panel, how many panels you got, then times this. If it is 10, then the inclination, the tilted, depends if it's installed directly on the roof or not. And then the orientation, let's say ideal orientation south. Shading, modest or no shading. So if they are directly connected, then yeah, so it's directly connected, then you say okay, it's not completed. Why? That's, let's say this kilowatts, sorry, that's so altogether 200 something times 10, so it'll be 2.5. Well, the house requires like at least 3.4 kilowatts. But let's say, yeah, 30. Why it's not south? None. Okay. Each flat goes to particular individual flat. Usually like this, but let's just put them here. Then we'll show if there is, but this is not usually. So the overheating, so I just considered quickly. Let's just move on. Cross ventilation not possible, so that will be assessed by the building assessor really, if it's possible or not. Then let's say it's possible, not usually, especially in the flats, but there's trickle vents here. Okay, let's move. No conservatory room. This is all just lights, so let's say 75%. There's lights here. Okay. Low energy lights here. Total lights in number. How many? Let's say 10. And low energy here. Let's say 7. That will come with 70%, not 75%. Right. So this is an overview of this, but you can see the building doesn't really comply with the regulations. The emission target, this will show where it is. So this is the emission rate, the target emission rate, and this is the dwelling. So you can see it's still performance less than the target. The target always relies on the construction of the building and this and this. I'm just conscious with time really. So you just, I know this is probably, we shouldn't spend that much of time, but let's just see reports here quickly. That's the report, that the SAP worksheet. So you will get all of this information from here. So I'm not really going probably. So this is the construction details, then the heating, the hot water, and the renewable will be at the end. So I just need to switch to this, the BAS 2035, and show you where we use this information. But Natasha, I think the time is flying really, or it flies. So this is the BAS 2035 compliance document, and this is the copy now. Well, there's a new one, but this is quite similar really. The first one is general guidance, and then you can see the project information, the assessor, the coordinator, and there's guidance below here, the evaluation. So just the reason why the client needs to do improvement. So it will be ticked here. So is it just concerning about the energy consumption, reducing this? Is it emissions? Is it really something to deal with health of occupancy? So list of this will be agreed on, and see to compare this against the performance. Then the risk here will just identify whether it's path A or B or C. Usually path A is less risk and safe. So it depends on the measures that you are going to improve. If it's up to 10, then will be considered as A, and within this be more than this. See, but this is not only this. The story is, if it is traditional building, that can, even within, if it's one measure or two, that will go to B or C. If it is heritage building or other type of buildings, then of course will go to type C. But this, the metric, the interaction metric here, will show you just like safe, or ensures that two measures can be installed at the same time and there is no inherited risk. So the same list here will be the same list here. So you select the measure that you're going to install or improve, and then the second column here, whether you have an installer, so quality assurance certificate. If there is, then you just provide it, let's say, and you see if it's green, then there's nothing to worry. If it's yellow, it's explained here really. So just a bit of details on the construction, how it's going to be installed. If it's orange, then there is a compatible specs required. So that's usually from the manufacturer. If it's red, then there is no way they can be carried out at the same time. So you include the measures here. So whatever the improvements here, and then you see the inherited or technical inherited risk here, whether it's high or not. And this will show here. So this will affect really the path that you're going to follow. So it depends on these criteria. So the number of measures that we selected, like 8, and the other one is technical risk, which is the inherited from installing these measures together, and then the combination of all of these risks. So either if there's 3, then that will be a combined here. So also, if the path is A, but it's still you would like to see an improvement option evaluation, then you have to click this, because it won't show if the path is A. Of course, this is going to path C. When you look at the type of the building, number of measures or improvement you're looking to improve. And then you go to the, this is just really an overview of the path C. So let's say the risk assist, and there's the activity to assess this, where you define this in the document, in the BAS 2035. So this is looking at the stages, and the activity will be carried against the standard. The measures here This looks daunting a little bit, but this explains a few things here. So one is the measures that you're going to improve and the quantity. This will be automatically, so the unit, and then the details of the improvement. So what is exactly? So you select, let's say here, if it is a dry lining, then you select this. It's just enter number one, type 1, and then the second one, this is a medium-term improvement plan. So if you're looking at which one probably be installed first, then you can structure like a plan to do them like within 3-4 stages. This explains later. And then there is a default data here, especially regarding the lifespan of each measure here. If it's insulation, then 36 years, let's say. So by default, it's putting the price, but you can enter your price here. But if you do enter any, especially if you want to compare different prices here, you have to select which option. So if it's option 2, you fill all of this, you select option 2, of course. And then this is just the VAT, and it gives you the total price here. So you go down here, select all the measures that you're going to improve. All the way down, you can see that's few being selected, but the number of the measures here, like fans, also is important. If it's 4, 3, 1, so some of them is by number each, some of them by area. So if it's area, then you have to select the area. It's well explained, really. So it's something pretty clear to me. So this is the measures here, and then the improvement. So here's where you I'm just trying really to look at the time. Not much time, but if you don't mind, everyone, we can exceed probably the 1 hour, another 10 minutes for Q&A. Now here, so you have the full SAP or PHPP. So we have really looked at the full SAP. Probably PHPP it requires more input data, but also is another option here. So all of this will be brought from that worksheet here that we saw earlier. Oh, sorry, where's that worksheet here? So everything will be brought from here. Oops. Okay. Brought from here. So let's say heat losses, no, heating demand, water heating energy requirements. Also hot water here. Not forget about this. Solar gains, main internal temperature, space heating. So energy requires for space heating. So water heating as well. So you see that hot water is there, electricity as well. Also emissions as well. CO2 emissions here. So you see the rating here. And all of this information will be brought from the SAP sheet. But you see, this is the readings of this, and then by installing, this is an individual improvement, really, not combination. So once you run this, it should really focus on individual improvements. So you put, so this is the existing scenarios that we have here. But when you install insulation, then just run a simulation on the improvement of insulation. Then you go for example, you add loft insulation, let's say, and you see that will affect the heating, probably won't affect the hot water or electricity, which is just like reducing the heating demand. Some will affect the other. So others here, like hot water, for example, if you're installing or replacing boiler, for example, if you changing lights here, that will affect the electricity, let's say, or the pump that you use for heating, for pushing the water, sorry, the hot water. Then for renewables here also, I've mentioned something on the worksheet, SAP worksheet, so you get some information from there. If you there is an option here that you install. Let's just close this. You install in the renewable here, for example, air source heat pump. Is it for ventilation or heating? So air source heat pump somewhere here. Heating. Air source heat pump. 1 second. So it's air source heat pump. Heat pumps with warm air distribution. So you can have warm air system. So if you have air source heat pump, then you can add it here, and you bring that information from the SAP worksheet. There's one here, another thing here, the packages you're selecting here. So you can even have different packages here. So package 1, for example, let's say like a quick let's say quick winner. This they call it, refer to quick winner, and you select which one for package 1. So whatever that available to the clients, so they can replace the boiler, let's say, or repair it. Then, and if it's combined, let's say package 3, it will be calculated later. Medium-term plan. So there's probably some interesting charts here when you look at the payback, simple payback period. Simply, it's just how much you invest on money and how much savings. So you can see how many years. Carbon cost effectiveness also, that could be a concern for the client. So it's something he wants to see the improvement. He wants to see how much carbon savings over time. So this relies on how much energy saved for when you install a new or you just improve the envelope, the fabric. So there's energy will be saved, but also carbon CO2 will be saved as well. But this relies on how much energy is saved and how many years that will be, which is the lifespan of the measure here. So it's quite simple, really straightforward. That's how much carbon savings, but also depends on the lifespan of the element that you improve it over time. Shows over 20 years, 30 years, how many CO2 equivalent, let's say in kilograms, you save it over time. Medium-term plan. This is an agreement with the client and shows your commitment with the client. So this will be recorded. So if there is anything that will limit your improvement in terms of history of the building or any other constraints, this also, if it's related to location, let's say scaffolding, it's hard to be install it like in the south facade or whatever. There's entrance, limited access, so anything that related to the location. So everything will be recorded here. If there is any defects that needs to be repaired before carrying out the retrofitting, other defects as well. And this cost will be based on your selection first, which option that you selected. As we said earlier, you can input your cost against each measure here. So this brings us to this. So you can put the sequencing here. So you selected these elements, 8 measures here, but also you can put sequencing, depends on the client, like budget, and how safe when you look at the interaction matrix here. So this is like, let's say, insulation. Is there any insulation here? France, that would be the first one. Yeah, so probably this would be first one, and then external wall, if it's available, let's say 2. Anyway, so this depends on the discussion between the designers and or the coordinator and the client. So which one, like let's say, is a quick win to install heating control. So would be 4, option 4, and so on, so on. Air source probably could be 5th option. Anyway, so you continue doing this, and you can list. This will take you to the interaction tab. So the measures tab here, say OK, and go to the measures tab and ensure that everything that you selected there is included here. So we'll show you just this will be brought from the simple payback period, so the cost that you estimated and the carbon savings. So it will be carried from the previous tab. Okay, stages here. So you can just really say this is stage 1, and your replacement of windows. Probably this is stage 2, like stage 2, and then these are the stage 3. Let's say you can define it in stages. Ventilation is the most concern, really. People, especially when they do improvement, then ventilation would be a concern, really. You could add a problem rather than solving a problem if your building is sealed well, so is airtight, and then you don't have enough ventilation, sufficient ventilation. This would be the test you did, let's say 10 cubic meter per hour at this pressure. An existing airtight estimate. So this is what your estimation, let's say 5. So this would depend on the survey, really. If there is an evidence of condensation, mold, let's say some, so you have to deal with it. So you have to suggest a proper ventilation system. Let's say there is no at the moment, undercut less beneath an internal floor. Let's say yes. If there is a provision of purge ventilation, so it's like habitable rooms, for example, openable windows. It just shows you there is a need to upgrade the ventilation system, and this just probably what the upgrade is all about. So are you suggesting an intermediate extract ventilation, so or let's say mechanical ventilation with heat recovery system, or just mechanical ventilation, continuous ventilation? If you carry out post-retrofit airtights, then you need to put it here, and what the reading is. Let's say you improve this to 5. So the air test certificate, if it's provided or not, as well, retrofit coordinator declaration. Yeah, this is a confirmation of that investigation is done about the installing the mechanical system or ensuring that a compliance with the standard in terms of noise, in terms of so it is sufficient or not, or complying with part F as well. So it's just making sure that, because BAS 2035 is not a standard itself, but it refers to British standard, let's say, building regulation, FJ and all these, which is here. So this is just safety of appliances. So it refers to this, whether it's compliance with that document or not. The last bit probably is looking at the if you're installing decentralized ventilation, then providing just the software or the document with the area of the property that you had on SAP and number of beds, let's say. So all of this will specify the occupancy and the needs. Let's say 2, let's say this is actual occupancy, 3 people. So we'll go with that, with the highest. There's three like strategies here. One relies on the occupancy, so a provision of fresh air for each person. The other one relies on the area and the volume of the space, really. The other one is the third one is relies on the minimum fresh air for the whole property, which is just the volume times the 0.3, which is the heat capacity, the capacity of the air to transfer the fresh air, or the air exchange, sorry, per hour, not the and now this is also this is the extraction. That's supply of fresh air. This is extraction, and the method that the document follows is the is how much air extracted from the wet area. Kitchen usually higher, but you provide the volume. Let's say the volume is 35. The bathroom will be lower, let's say 25. And then we show whether this is the extract air is enough or not. So it should relatively similar to the fresh air, not more than the fresh air. So you will be extracting more air if the extraction system is higher than the supply system. I won't really go deeper into this, but this is ventilation is interesting topic, but I don't think we can dig deeper into this. It's just I hope that I gave an overview of the compliance document and probably the SAP, what information that you need from the SAP that requires the software to give you like an accurate data or calculation.